So if you wind up with questions over the stuff about yesterday, let me know. Shoot me an email, text, whatever. But the video from yesterday's class time was corrupted because my iPad got super grumpy. So just so that y'all are aware, I didn't forget to upload the video, though that is a valid ask because I forget all the time. This is 6.5. Okay. So what we're going to start doing is we're going to start graphing sine and cosine. And a few days ago, I showed you a very brief animation on what these look like. They kind of look like waves. But today we're going to actually properly do it. And one thing that's important for us to know is that we're going to count by weird units on our x's. Since there's no numbers on there, we get to decide what it counts by. And we'll talk about what we're going to pick a y in a second. I'm just going to do this. So what we're going to do is we're going to think about this in terms of our unit circle. So I'm going to give myself a little super basic sketch of my unit circle. And literally the only points I'm going to put on here are the ones that are the quadrant points. So I'm going to put my 1, 0. I put that way close to the top. I have no space. 0, 1. This marker feels super chunky. Oh, it is slightly super chunky. Our -1, 0. And our 0, -1. I'm going to switch that top one to be the skinny pen because that feels super cramped. Right? Those guys match up. And what we're doing is we're going to take the value of sine, and x is the theta. It's our angle. So it's going to feel super weird. I promise it'll make more sense as we go through it. Which of these points is our sine, x or y, on the ordered pair? The y. So these are sines. So we're going to be starting with these ones. So when we're going around these circles, what are we counting by? Pi's. So we tend to go like pi over 2, 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2. And it like keeps going around and around and around and around, right? So what we're going to do on our x's is I want to be able to count kind of by pi's, but I also don't want them super duper squished. So the way I'm typically going to count, now occasionally I'll adjust, but I'm typically going to give myself pi over 4s. So I'm going to do this one as pi over 4, pi over 2, 3 pi over 4, and pi. So I'm really going to be skip counting by pi's by 4s. That sentence made no sense. 1, 2, 3, 4, and that's a pi. 2 pi. You okay? So I'm going to make 4 units on my graph equal to 1 pi. 1, 2, 3, 4 minus 2 pi. Because what we're going to do is we're going to say, okay, when my angle is 0, what is my sine? 0. When my angle is pi over 2, what's my sine? 1. When my angle is pi, what's my sine?
-1.
0. You jumped too far. Okay, we're going around our circle this way. When my angle is 3 pi over 2, what's my sine? -1. So that means we need our 5 pi over 4, 3 pi over 2. Yeah, so then we're down to -1. And then it goes back to 0. And then it goes up to 1 again. because it goes around and around and around. All we're doing is changing our angle. The x is our angle. So it's not going to like go off to infinity or anything. We could even go the wrong direction. If I go for my negative pi, that goes the wrong way. So then it would go down to -1 to go this way. If I go negative pi over 2, that's right here. And we have a -1, sine is -1. If I go negative pi, my sign is back to 0. What? There we go. If I do negative pi over 2, we wind up here. And so it's going to look like this. So the sine graph, when we start to connect these up, looks like this. It makes a squiggle. It's a sine curve is what it's called. And it will repeat forever and ever and ever and ever in both directions. So instead of having to try and graph a forever and ever and ever, we have a few ways we talk about pieces of it. So if we notice that it like repeats, I've got high, low, high, low, high, low, high, low. It keeps going. So one section of that, I'm going to start at my 0 here, to the next time it hits the start. So one section where I've gone both high and low, right? That is called a period. That is one period of my graph. And we're going to measure it as a unit of length. So the length of one period is also the amount of time it takes to go all the way around my circle one time. And for our basic sine function, it's 2 pi. That's how many radians it takes to go all the way around my circle. When we're talking about our period, it's helpful so that like when we're talking to other people or writing things down, we can know like where the period starts and where the period ends. So we're going to call that our left end point. And that's a lot of words to write. So we're going to refer to that as the LEP because we are lazy people. Left endpoint is going to be at 0. Our right endpoint, so it's the right side of our period. This is our right end point. Again, the only time I'm actually going to write all 3 words out, I'm going to call it the REP. Is at 2 pi. This is just the endpoints of the period when we're starting at 0. So if it's 0 to 2 pi, that is that first time through our circle. And we already talked about our period being 2 pi for the sine function. What is the domain of a sine function? All real numbers. It goes from negative infinity to positive infinity. I can take the sine of any angle. We've done some funky angles. What is the range?
1 to -1.
Yeah. When we write it, we switch it, but talking about it, I don't care how you say it. Our smallest value is -1. And our biggest value is +1. So we have a lot of pieces in here. A lot of pieces in here. Questions on any of the pieces? Because y'all know we about to play with it like it's made of Play-Doh. Because we're not just going to have you say, graph sine of x. Ta-da, you're done. We're going to do funky things with it. Okay. The next couple I'm going to do like kind of stacked on top of each other. So I'm going to draw the sine graph again, but then we're going to do something called an amplitude change. We are going to have a full transformation form. This is the full transformation form for sine. A, H, K, B, we're super familiar with them. They do all the same things as normal. We're just going to treat them a little bit weird. What we're going to look at on this first graph is we're going to look at A, amplitude changes, and what that changes. So first thing I'm going to do is I'm going to graph my sine of x again so that we can see what happens compared to our parent function. So I'm going to count the same way. We're going to start at 0, and I'm going to skip count by 4 by pi. 1, 2, 3, 4 gets me to pi. 1, 2, 3, 4 gets me to 2 pi. 1, 2, 3, 4 gets me to negative pi. 1, 2, 3, 4, negative 2 pi. That is going to be the most common way that is the easiest to count by. Not saying you have to. If you want to stretch things out further, you can, but it will make things a little more complicated. The benefit of doing it on pi's on 4s is that whenever we hit a proper pi, we're at 0. Halfway between it's up at 1. Halfway between it's down at 1. So it's the same function we just did. Whenever we're at pi, it's hitting 0. And halfway between your zeros is when it goes up or down. So here's our sine of x. And I did this one in black. What our A value does is it's going to change how high the bumps go. So it changes what's called the amplitude. And we're going to list it as the absolute value of A is the amplitude. Because we'll have to like I can't spell and talk at the same time, especially a word like amplitude. Oh shoot, it's right above where I was writing. Goodness gracious. Did I even spell it the same? Yay, I spelled it right. The absolute value of A is what we call the amplitude. That is the extent of what I've told you so far on it. And what it does is we're going to take those ones, or the negative ones, and we're going to multiply it by our A. So what was 1 is going to become 3. 0 times 3 is still 0. Negative 1 times 3 is negative 3. So we're going to take all our values that we have and multiply them by our amplitude. So the zeros are still 0. The 1s become 3s. The negative 1s become negative 3s. So for our g of x, which is 3 sine of x, it's going to look like this. And what it does is it changes this height by the absolute value of A. Hi. So it changes this height by the absolute value of A. And what that does is it changes it off of what's called the midline, which is right here. It's the middle of our sine graph. So it raises everybody the amplitude off of the middle. Questions on g of x? Because we go do the same thing with h. Yes, 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 yes. Yes, yes, yes. I'll give some time. Absolutely. Yeah, it's a lot. Oh, yeah, there's a bunch of graphs, and I may have not put a giant pile on that table. Here, I've got more. Yes, I see that. Thank you. I just think it's good. I can double check that it actually goes in the Okay. All right, the general should better start back up again. We ready to try H? Okay. So it's the same kind of thing, and I'm going to draw it on the same graph again. Like, I'm just stacking these up so that we don't have to use 30 graphs in our notes. And all it is we're going to take whatever our values are, our amplitude, we're going to take our high points on our sine, and we're going to multiply it by half. So it's still going to start at 0. I'm going to do, just so we're clear, I'm doing h of x in green. So it's still going to start at 0. But this time, instead of going up way higher, it's going to be a half. Okay? So it's still 0 when we get to pi. When we're at 3 pi over 2, it's at a half. When we're at 2 pi, it's still 0. When we're at 5 pi over 2, we're at a half. Yep, it is smaller than my sine curve because our amplitude is a half, so it's been compressed. So it's very much like our stretch and compress back in the day of all the other graphs we've ever done for forever. A is still doing a stretch or a compress. It's just hitting all the points. Okay. Ready for the next one? The next one I'm going to put on a whole new graph because we're done with amplitude changes. You've seen what an amplitude change is. That's what our A is on our equation. Why won't it let me zoom? That's not what I meant. Undo. Thank you. So our amplitude changes come from our A. Next, we're going to talk about something called a period change. It's going to change the length of our curve. And that's going to come from the B value. So our B value plays with the length of the period. So I am again going to just toss the sine curve up there for us so that we see it, so we can compare. I'm going to put my f of x is sine of x. And I'm still going to count the same way. We're going to have our 0, 1, 2, 3, 4 is pi. 1, 2, 3, 4 is 2 pi. What do you mean?
Like we did the A value, now we're going to B value.
Now we're going to look at the B value. Because they change things in, it's doing the same thing that it's always done, but it feels super weird because it's a trig function and not like a normal graph that we're used to.
So like that feeling we're going to do like all of this.
We'll have H and K as well. But we kind of approach these in a different way. So instead of tossing everything at you all at once, I'm trying to be nice. Maybe a little bit, but it's still trig, so it's still kind of mean. So we're going to have our zeros on all of our pi's for sine. And then it goes up 1, down 1, up 1, down 1, up 1, down 1. This is the regular one. This is plain sine of x. It's also great practice for us to draw it several times because they're weird, super weird, extra weird, annoyingly weird. And our original function has a period of 2 pi. That's how long it takes us to go around our circle. What B does, and the way we find our new period length, is that our new period length is going to be 2 pi divided by whatever the B value is. We're going to use absolute value of B. So for the sine of 4x, what we're going to do is we're going to take 2 pi and divide it by 4. So that means the length of the period here is pi over 2. That means when I'm looking at my graph for the sine of 4x, I need to fit the whole of the function in here. So I'm going to take my whole sine curve, my whole period, where it went up and then down, this whole guy, and we're just going to go squish. This whole curve is going to fit in that little gap here. So it's going to go, in that little gap, it's going to go up, down, and hit. One whole period fits in that gap. So sine of 4x means it squishes. So then another pi over 2 fits a whole another period. We're going to go up, down, hit. Up, down, hit. Up, down, hit. So I can fit 4 whole periods in the normal sine curve. I got it. Hi. Welcome back to chaos. We're graphing these and they're weird. Okay. So, and it continues in both directions. I'm going to get rid of these little lines that I drew here. So it does the same thing the other direction. So if 4x makes it squish, super duper close. It does that horizontal, compression. Oh my gosh. Let's look and see what happens with this P of x. To see how its period changes, we do 2 pi over 1/2. 2 pi over 1/2 simplifies down to, try that again. 4 pi. So we get to stretch this one out. The whole period takes 4 pi. So instead of going up and down in the length of 2 pi, I need to go all the way to 4 pi, which I don't even have the space for on here. So 2 pi is going to be a half a period. So it's just going to go up and back to 0. And this one's going to go down, back to 0. So we now have a new period that's twice as long. And I'm going to draw the period lengths on here. So this is our pi over 2 period length. I'm just doing like the location of these is not a thing. This is just showing this was 2 pi. This one's our pi over 2, and this one is 4 pi long. It takes the whole 4 pi to get through one cycle of down and up. I only went to the left because I don't have any more physical space on the right. It should go up and then down this way, but we have no space because these graphs are already too dang big. There, and the rest of our sine curve. So it should come all the way up to 4 pi to be one whole period of the graph. They're weird. I know they're weird. The purple one, it takes a period of 4 pi. It should still go to the right, but we don't have enough graph over there. Okay. We're going to do one more, because we haven't talked at all about H or K, but K is literally just moving the whole middle of it up. H is a little bit weird because it plays with those endpoints we talked about. So we're going to take our first, like for realsies, I'm not going to graph sine on it, we're just going to play with this guy. So I'm going to count by the same unit. So I'm going to label my stuff again. 1, 2, 3, 4. Pi. 2 pi. Minus pi. Minus 2 pi. And we're doing the sine of the quantity 2x minus pi over 2. So what we have in here, when we have something like this, this means our starting 0 has been moved because we have had an H, a horizontal shift, right? The way we figure it out, where our period starts, where that first 0 is we set this piece equal to 0. That's our left endpoint. So we're going to take that 2x minus pi over 2, and we want to know when it equals 0. How can we figure that out? Add pi over 2 to both sides. This is this chunk. So we're going to have 2x equals pi over 2. So at what x value is this going to start? When x is what? What does x equal? over I think I heard it whispered. Pi over 4. Divide both sides by 2. So pi over 4 is our left endpoint. So we're going to start here. That's my left endpoint. To find our right endpoint, it's very similar. We're going to take our 2x minus pi over 2. And we're going to set it equal to 2 pi. We want to know, when does this cycle end? When does it get all the way around that circle one time? So we set it equal to 2 pi. Same vein. What do we do here to solve this? More specific than same thing. Add pi over 2. So that gives us that 2x equals 2 pi plus pi over 2. 5 pi over 2. So where is our right endpoint going to be when x is what? Five pi over 4. Which is just past pi. So this is our right endpoint. Then let's figure out the length of the period. We do that by taking our 2 pi and dividing it by the b, 2. So what is the length of the period? Pi. And in fact, that's exactly what we see here, because that also should be the length between the left endpoint and the right endpoint. That's our period. Do we have an amplitude change here?
No.
No. So our amplitude is 1. There's not anything multiplied in front. So we know it's going to go up 1 and down 1. It also needs to hit 0 in the middle. So the way we can do this, when our period has changed, halfway between is going to be another 0. Then in between that, it's going to go up our amplitude, down our amplitude. Up our amplitude, 0. Down the amplitude, 0. So it's going to look like that. So they're weird and they're super awkward to get to. Our domain here is what? All real numbers. We're from negative infinity to positive infinity, just because I always write them in interval notation for us here. And what's our range? Negative 1 to 1. Okay. So we have 2 minutes, probably closer to a minute left. In the little tray on the way out, there is a packet for homework 5, because it's all graphs. And instead of you guys having to freehand stuff, it is literally these graphs. Like it's the same paper, the same graph. So it does have 8 graphs, so it's stable. It's a packet. It's 8 graphs. It's sine and cosine graphs. And we will do more of those tomorrow and Monday. There is also available, if you want it, I'm going to have it on my little desk over here. As soon as I put my hands on it. A review for the quiz, for quiz 2. Which I have The reviews for quiz 2 are right here, so it's a paper for that. So reviews for quiz 2 by the tree. Homework 5 is in the tray by the door. I'm gonna duck dodge and get out